Okay, so last time we went over a lot of terminology that we're going to use in designing an experiment. Now we're going to look at how do we actually set up the experiment. How does it look whenever we design it? So we're going to look at 3 different types of experiments and how they are designed, how each one is put together. So the first one, the completely randomized design, this one is very similar to that simple random sample. Okay? It's where everybody is left as one big group. The whole population or the whole group of experimental units is one group, and we randomly pick from that group. Okay? So when we set up our experiment, what we normally do is we'll draw out the design as kind of a flow chart of this is how it works, and then we write up the randomization procedure separate. So that's how we're going to kind of do it on here to show you this is how you would do one. So anytime you have a completely randomized, you're going to start with your experimental units. And that can be a group of people, it could be a field of corn, it can be a herd of cattle, whatever it is that you are imposing the treatment on. Okay? Whoever is receiving the treatment. So we start with them, and then we randomly assign to the treatment. So we're going to draw this up as though there are only 2 treatments, but realize there could be more. Okay? So from there, you're going to assign them to the treatment. So this is going to be treatment group 1. And treatment group number 2. Okay, so we've taken our experimental units, we've assigned them to treatment, then we want to measure the response variable. And remember, one of the things that we have to have in an experiment is that comparison. So we want to compare the response variable in each one. So over here, we're going to say compare the response variable. Compare the treatment 1 group with the treatment 2 group. Now, if we had an actual experiment that we were designing, all of these would be written in the context of what the experiment is. Okay, we would say we have 100 middle-aged men that are going to have this treatment and this treatment, and we would write out what is the treatment they're getting. So normally all that would be context. Now the other thing that is required, you have to show where did the randomization happen. Remember, randomization is the required element. We want to show that within our design. So we're randomly assigning these experimental units to the treatment. So we're going to write the word random in there to show this is where the randomization happens. Okay, so over here on this side, we're going to put some notes about this one. Here are experimental units randomly assigned to a treatment. We talked about this yesterday. That order that you write it is important. You want to make sure that the units are being assigned to a treatment. And when you look at the diagram that we just drew, you can see that's the direction of assignment. So you want to make sure that is clear as well. The other thing is you must describe this process. So you have to say, how are you going to randomly assign? You can't just say, I randomly assign these subjects to this treatment, and this is my result. You have to describe how the randomization happens. So, some examples of randomization techniques. You could use a random number table. So you guys should all know how to write that up. You need all of those details that we talked about with writing up how to use a random number table. All of those should be included. Okay. You could flip a coin. If you are only assigning to 2 different treatments, then you can do a coin flip. If you have 3 or more, obviously a coin flip is not going to be the way to do this. So you would say, for each experimental unit, for each subject, or for each plant, or whatever you're assigning to, for each one I would flip a coin. If it lands heads, they would receive, and then tell what treatment they would receive. If it lands tails, they would receive, and then explain that treatment. You have to cover every option of what could happen. Okay? You can't just say, if it's heads, they go here, and just assume they know if it's tails, they go to the other one. Can't do that. You have to describe each possible outcome and what would be the result. Okay? So, flipping a coin, that's one. Another one, you could draw names from a hat. Or draw numbers or whatever it is that you want to do. Now, when you're drawing names from a hat, you want to be careful that you include all the steps. You want to make sure that you say, I write each participant's name on a slip of paper. I put all the pieces of paper into a hat. I mix them well. If you leave out that mix well, you lose points. You have to show that you mix it up, because otherwise, the ones that you put in last are going to be more likely to be chosen. So you have to show that each one has an equal chance of being chosen. So put all the names in the hat, mix it well. I started with 100 people, so I draw out 50. They get this treatment. The remaining 50 get the other treatment. Okay? So you've explained how each person is assigned. Okay? So make sure you describe each step though. And there can be other things, but that gives you some examples of things you can do for randomization. Questions so far? Okay. So that kind of takes care of the completely randomized design. This next one, randomized blocks. This is where, remember yesterday when we talked about confounding variables? Remember this discussion? We said sometimes there's something that could be influencing our results that's not our treatment. It could be that men and women react differently to the type of shampoo being used. Or it could be if we're looking at testing some other part. Let's say we're testing the type of shoes they like. Which brand is better? Well, men may prefer one and women another. So there could be a difference. It could be the age of the person makes a difference. If we're looking at workout routines and which one helps improve blood pressure, we could look at 20 to 30-year-olds and then look at over 50-year-olds. We may get different results for the same exercise in the 2 age groups. So sometimes the age of the person will have an effect on it. So you have to think about all those confounding variables, and that's where the blocking comes in. Anytime we think there's another variable that could influence our results, we block on that variable. So here's how this looks. So we take our experimental units, we're still starting with them. But now, instead of going straight to the treatment, we think something else could be affecting this besides the treatment. So we block on that. So the first thing we do is we say, what could be affecting it? That's what I want to think about. Now, don't overanalyze this. If there is a problem where blocking is needed, they will say, we believe men and women may react differently to whatever it is. So that's going to be your clue to block. Okay, if they don't say something similar to that, don't try to force blocking into every problem. But they will give you some indication. So in this one, we'll say we're going to divide our experimental units, and we'll say block 1, we'll say that's the men, and block 2 will be the women. We're going to say gender may play a role in the results. So we're going to split them up by put them into blocks that are similar. Then within each block, that's when we assign to the treatments. So for the men, some of them get treatment 1. And some of them get treatment 2. And same for the women. Each block receives each treatment. So I don't want to compare how these two compare with the women. I don't want to compare men and women to each other. So when I go to compare the response variable, I'm going to compare men to men and women to women. Still need to make sure it is clear where the randomization happened. So I have to think about it. Did I randomly decide which one are men and which one are women? No, they already were one or the other. So they got assigned based on what they already were. Then I have to say, did I randomly assign each of these to the treatments? Yeah, that's where the randomization occurs. So that's where I want to write this in. So there's my random assignment. And of course, just like we did in the completely randomized, you would describe that randomization process in detail. Okay, so let's look at a few notes on this one. So when we have a situation in which groups of subjects are similar, it is often good to group them into blocks. So examples of things that we may use to block. Just like we did in this example, you may sort men and women into different blocks. Like we talked about, sometimes teenagers and senior citizens are going to be different in how they respond to certain treatments. So age is something that may be appropriate to block with. Another one, let's say we are looking at exercise programs, and we are wanting to evaluate which one of these two programs is better. We want to think about the activity level of this person that's participating in this before they were a participant in this experiment. Were they someone that never worked out, or were they someone that had a regular workout routine? Because those two different types of people may respond differently to the exercise program. Okay, we don't want to compare the wrestling team with people that just watch TV all day and don't do anything. It's like we want to compare like groups. So if we separate them and put all the athletes competing against athletes and the non-athletes against non-athletes, then we would be more likely to get better results. So maybe activity level could be something that we would use to block. So like I say, when you get to a problem that uses blocking or that should use blocking, it will give you some indication. Okay, it will say we think that people who are on a vegan diet may react differently to people on some other diet. So it may be that they give you some indication. If that happens, that's when you block. If you don't see any of that, then don't worry about blocking. Okay. No questions? All right, matched pairs. This is our third one. This is very similar to the blocking, to the randomized block. This is where we take our group of, this is going to have, you're going to need to write small. Sorry. So we have our experimental units. And now, instead of putting them into blocks, we're going to put them into pairs. This is a matched pair. So, we're going to put pair 1. And we would keep going. I'm not going to write all of them, all the way up to pair N, depending on how many we have. Normally, This is a person paired with themselves. Okay, so they're going to try out both treatments and report the difference in how they work. Okay. Sometimes it's two different people paired together, but it needs to be some sort of natural pairing. That can be like identical twins. They would pair them against each other. This twin gets this treatment, this twin gets the other, and we compare them to each other. It could be siblings. It could be a husband-wife. Could be paired if we want to look at do people married less than 5 years have a different compatibility than people that were married more than 20 years? Is there a difference in it? So you would look at this husband-wife paired and this husband-wife paired. So some sort of natural pairing, there needs to be a reason that you're pairing. So don't just do it. Most of the time, this one's going to be the one you're using is completely randomized. These other two are more unusual, but when they're needed, they make a lot better design. So if this happens, this is not randomly done. There's a natural reason to pair what we're pairing. Then each pair gets each treatment. So it's like each pair is its own block. This is where our randomization would happen. So I'm going to say random reassign. Sometimes people write randomly assigned. Sometimes they'll write random assignment or just the word random. I'm going to show you different ways that this can be done. But you need to indicate somehow where the randomization occurs. If you're having the same person try both treatments, you randomly decide which one goes first, which one goes second. Okay, so they may be trying two different exercise routines. They do the first, they randomly pick which one they start with. They do that workout for 6 weeks, then they do the other one for 6 weeks. Okay, each person is randomly assigned to whichever one to start with. So they're not all doing the same thing, because if you had everyone in the whole group do exercise A and then everyone in the whole group do exercise B, they may do better on B just because they've already done A. So we want to randomly pick which order they do these, and then we can compare the results of each person to themselves. So when we do our comparison, we're comparing this pair to each other, this pair to each other, and this pair to each other all the way through. Okay? So compare response variable for each pair. Obviously, if we are doing something and we have like 15 pairs, you do not have to write all 15 pairs. write a couple of them to get the pattern going, and then show you go all the way to pair 15, and that's good. Okay, you don't have to do 15 of those. That would take forever. Okay, so a few notes on matched pairs. So most matched pairs use the same person as their own control. This person gets both treatments. In a random order. So this could be, like we had a question a few years ago on the AP exam where they wanted you to test two different kinds of socks. Okay, so brand A sock, brand B sock. And so we did it as a matched pair so that each person would wear one of each sock. Okay, so they randomly picked which foot sock A would go on and then sock B would on the other one. That way the activity level is the same. Whatever they did with one foot, they were doing with the other foot. So it should have the same kind of wear on each sock. And then they had them rate how well they liked the sock. So that would be a matched pair. Okay, randomly assign each treatment to that person. Some paired designs use two people or things that are naturally matched. Such as identical twins, or husband and wife. So it must be some natural type of pairing if you're going to pair two different people. Questions so far? We're going to look at some examples of this, but so far questions? Alright, so here's where this should go on your table of contents. So that's page 31. That's the ones that we just finished. once you get that, this one that says experimental design examples, it's a little half page that's in your notebook. This is where we're going to go. This is going on page 34. So that's what we're going to go to next. Okay. Okay, so what we're going to do is this paper will attach on page 34, and then we're going to just write our examples out on page 35. So they'll be right there beside each other. So this on 34, and then we're going to write on 35. This is page 35. So our examples, it says that Acme Medicine is conducting an experiment to test a new vaccine. Okay, they have 1,000 volunteers of adults aged 21 to 70. In design 1, we're doing a completely randomized design. So here they say they take all 1,000 researchers. That's our experimental units, or 1,000 volunteers. And it says they put all 1,000 names in a really large hat. They stir it up well, and then they draw 500 names for the vaccine group, and the remaining 500 get the placebo. So these get assigned to either the vaccine or the placebo. So those are our treatments. That's what goes in there. And this was our randomization. Then it says, over the course of several months, the researcher tracks and records the number of colds reported in each group. That's our response variable. So we're going to compare the number of colds reported. So that would be our completely randomized design. You can see it looks exactly like it did in our notes. We just put the context in. Questions on that one? For design number 2, is randomized blocks. So now they think there could be a difference. So you'll see here it says they decided to separate the participants based on gender because it is known that men and women react differently to medication. So they're going to tell you something like that if you're supposed to block. So we're going to take those 1,000 volunteers. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . going to separate them into men and women. And then within each of those blocks, they're going to get each treatment. Within each block, we compare. What do I still need to add? Randomization. Make sure you put that in there. So our randomization happened right here. We'll get to the third one tomorrow. Hopefully that gives you an idea. Okay, guys, don't forget problem set number 7. You need to try to do that tonight.